Hi guys, and welcome back to another video on Fluent assertions where we'll be looking at object graph comparison. Now that sounds really complicated, but all it means is that we're going to evaluate two objects based on their structure rather than on their types. Let me give you an example. We will create two classes. One we'll call test and the other one we'll call test DTO. These will have two properties, a name property and a value property. Just quickly get this typed up and copy, and here's our test DTO. Now these look obviously exactly the same structurally, and we will also instantiate them in our unit test with the exact same values. So we've got test, which is a new test with value 1, 2, 3, and a test DTO test value 1, 2, 3. Now, if we wanted to assert this using standard XUnit, we would have to assert these properties one by one. We would have to say assert dot equals and then test DTO dot name and test.name, and then we'd have to do the exact same with value, and obviously this will pass in standard XUnit. And the reason we have to do it like this is because when we use equals or assert equal in XUnit, it expects the same type, so we can't just turn around and say, okay, I want to use test DTO and test. It has a compile time error because it says, hey, test is not test DTO. They're not the same type, so we can't do this. This is where Fluent assertions comes in again, and what we can do is make use of the be equivalent to extension, and this will essentially traverse through the objects and check each of our public properties. So what we can say is test DTO, because this is what we're asserting against, dot should dot be equivalent to, and then test, and this will pass outright. Now in the current situation this passes perfectly, obviously. If we were to change one of these values on name, for instance, and this can be called, we'll put an X in there, and we run this again, then the test will fail because the objects aren't the same anymore. The object graph is different. Now this could be exactly what you expect, but you also might not want this to happen. There might be situations where you expect something slightly different. It could be that this name field is actually confidential information and you want to replace it with asterisks, or it could just be that the value is different, that it gets compared differently and there's a different expectation for it. What we can do in that situation, if we say, hey, actually we never want to test against name, we can pass in a set of options to our be equivalent to function just as a lambda. So we just say into options, and then we can say dot exclude, and that will exclude a specific member. We can say excluding t into t dot name. Now if we run this again, we will pass. We'll put this back exactly how it was, so we'll remove these options, and we'll put this back so our test passes again. Now if the objects don't match in structure, then this will also fail, and it will fail because there's a property missing that it can't test against. So if we were to remove, say, value from our DTO, and we'll also remove it from here, and run this again, this test will fail. And it will fail because the properties are different, the structure is different. This doesn't have a property that this has, so they're structurally not the same. Again, we can tell Fluent assertions to ignore this by using our options, and we can say options and then dot excluding missing members, which will say, hey, if it doesn't match exactly on the members, I don't care about that. It's fine, carry on, I just care about what is there. And again, you can see that this is pass. We also have the ability to force the changing of a type. So, for example, if we were to put value back in here, but in this situation, in our test.dgl, the value is an int, and we'll just change this to be an integer here, so 1, 2, 3. If we were to run this immediately, it will, again, of course, fail. It will fail because we're expecting value to be a string, but we found an int 32. But we can, again, make use of our fantastic options to do an auto conversion. So we can say with auto conversion for, and then we can pass in its path. So we can say path that contains value. And now if we run this, it will pass again because it will be able to coerce the integer of 1, 2, 3 into a string of 1, 2, 3. Oh, I'm debugging it. That's why it's taking so long. There we go. And that has now passed. If you want to do auto conversion for every object, you can also do that just by saying with auto conversion. And then we'll run this again and we will get the same result. Now, we're coming to the end of this video, and it's just a couple of things that's worthwhile to mention if you're going to use the be equivalent to extension. Be equivalent to is recursive by default, so it will not just test these, it will test any nested objects. So if you had an address class here that it was testing, then it would also go through and test those. We can also turn that off again with our extensions by saying excluding nested objects. But if you do want it, it's worthwhile also to say that it will only go 10 levels deep into the recursion. This, for most people, is more than enough because objects are, well, if you get 10 levels deep, you've got a very, very complicated object. But what you can do is, if you wanted to say go unlimited, you can just allow infinite recursion. And that's going to be the end of this video, guys. Thank you very much for watching. Don't forget to like and subscribe, and I will see you all in the next video. Cheers!